From knowing that BF is a median, we can conclude that it connects midpoint to opposite vertex. So we can conclude that F is the midpoint of that side of the triangle AC, and therefore AF is congruent to FC. I don't see that as one of the answer choices, so I'm going to keep moving on and see what conclusions I can draw from the other segments. We have altitude BD. An altitude is just a perpendicular line. So the only conclusion that I can draw from knowing that BD is an altitude is that it creates two right angles. Angle BDC and angle BDA. I don't see that as an answer choice. Finally, we're told that angle ABC is being bisected by segment BE. That means on either side of BE, we are having congruent angles split by the bisector. So that's angle ABE congruent to angle CBD. Be careful. It's not ABF. It would be ABE that would be congruent to CBD. So that one here is incorrect. If we take a look at the answer choices, answer choice 1, angle FAB, which is this angle over here, and angle ABF, we don't know anything about the relationship because we don't know if triangle ABF is isosceles or not. They don't give us any information, so I can't conclude that for sure. If I take a look at answer choice number 3, CE, congruent to EA, we don't have any reason to believe that because the midpoint of AC is F, because the median is BF. So that means F is the midpoint. So AF would be congruent to FC. And then finally, we have CF congruent to AF. Oh, that's the right answer. That AF is congruent to CF. I didn't see that one at first there, but that's correct because F is the midpoint. So AF is congruent to CF. Okay, let's move on to number 2. Here, we have a diameter, and I'm just drawing a picture. It's not accurate. And we need the equation of the circle. In order to write the equation of the circle, we need 2 things. We need the center and we need the radius. So first I'm going to get the center. And the center is just going to be the middle, the midpoint between the 2 endpoints. So I'm going to really quickly use midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. And that's 2 plus 2 over 2, and 0 plus negative 8 over 2. And that gives us 2, negative 4. To find the radius, I'm just going to take the center and one of the endpoints. I'll just take 2, 0. Looks easier for me to work with because it's got a 0. And I'm just going to find the length using the distance formula. And that length will be the radius. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And if I plug in 2 minus 2 squared plus negative 4 minus 0 squared. So I have 0 plus 16. And that works out to be 4, a very nice number. So when you're writing the equation of a circle, remember the equation has the format x minus h squared plus y minus k squared equals to radius squared, where h and k represent the center of the circle and r represents the radius. So on the right hand side, we should have radius squared. So 4 squared would be 16. So I should see 16. So I can eliminate 3 and 4. Also, keep in mind that since there is a built-in minus in the equation, you're going to see the opposite sign for the x and y coordinate in the equation than it actually is. So if my x coordinate of the center is 2, which it is, I should see a minus 2 in the equation. And if my y coordinate's a minus 4, I should see a plus 4. And that's answer choice number 1. We're going to use a lot of the same ideas in 3, except in this one, we have to convert it into the standard form for the equation of a circle so we can see the center and the radius. And we're going to do that by completing the square. What I'm going to do first is I'm going to put the x terms next to each other, and I'm going to leave a box because I'm going to have to find the number that makes it a perfect square trinomial. And I'm going to put the y terms next to each other. I only have one y term, so I'm going to use 0y as a placeholder. And then I'm going to leave a box because I need to find the number that completes the square. The constant should be by itself on the other side of the equal sign, so it's already in a good spot, that negative 27. And then if I'm adding two numbers to the left, I have to also add them to the right. Remember, the easy way to find the number that completes the square is by using the formula b over 2 squared. For the x coordinates, 12 would be our b coefficient. So b over 2 squared would be 12 over 2 squared. That's 6 squared, which is 36. So 36 is the number that completes the square. And remember, the easy way of factoring, because it's going to be something multiplied by itself, because perfect square trinomials always factor to a binomial repeating. And the easy way to figure out what it factors to is the b over 2 before you squared it, which is 6, positive 6. Let's find the number that completes the square for the y terms. 0 is the b coefficient. So 0 divided by 2 squared would just be 0. And then when we're factoring that, it doesn't matter if you write plus 0 minus 0, it doesn't matter. 0 doesn't have a sign. And now let's clean up the other side. Negative 27 plus 36. And that's positive 9. So remember, in our equation of a circle, r squared is on the right-hand side. So this isn't r. This is r squared. So radical 9, which is 3, is our radius. So already I'm going to knock out choices 2 and choices 4. And then remember, the equation of a circle has the built-in negatives. So it's opposite signs. So in the equation, since I see a positive 6, it's going to be a minus 6. So the center is minus 6, 0, and a radius of 3. We have triangle ABC. I'm going to draw a picture because they don't provide us with an image. And BD is the perpendicular bisector of ADC. And since it's the perpendicular bisector, it creates right angles. And it also splits in half because D is the midpoint if it's a perpendicular bisector. So it says which statements can be proven. BD is a median. That is true. It is a median. It connects midpoint to opposite vertex. BD bisects angle ABC. Well, let's see. We don't have that information right away. But if we look at it as two triangles instead of one, the two triangles share side BD. So it's congruent to itself by the reflexive property. So the two smaller triangles are congruent by side angle side. And once we have congruent triangles, we know that corresponding angles are congruent due to CPCTC. So this angle ABC is being split in half. BD is bisecting it. Triangle ABC is isosceles. We don't have any, we actually do we have a reason to believe that? Let's see. Using CPCTC, we can also say that these sides are congruent of the two smaller triangles. And yeah, in the big triangle, that would mean these two sides are equal. So absolutely, triangle ABC is isosceles. Look at that, we can CPCTC so much stuff. So the correct answer is answer choice number 4. Okay, here we have medians that intersect at point P. So point P is the centroid. And we know that the centroid splits the medians in a 2-to-1 ratio, so we're going to keep that in mind. We're told that AB is 26, AC is 28, and PC is 16. We're looking for the perimeter of triangles CZA. We already have side AC. That full side's 28. And since the whole side AB was 26 and we do have medians, medians connect to midpoints. So Z is the midpoint of the side. So it's being split in half. So this is 13. So all we have to do is figure out this piece of side ZC, ZP. And we already know the longer part of that median is 16. And we know that there's a 2-to-1 ratio. So the one part's going to be half of that, it's going to be 8. So altogether, this would be 24. So we can do 24 plus 28 plus 13. And that gives us 65. Here we're told that the triangles are congruent before and after the transformations. So we know that rigid transformations occurred, producing congruent figures. Triangle ABC maps onto triangle A prime, B prime, C prime after what? What we should do is we should actually try out the transformations that it's suggesting. So I'm going to start with 4. I'm going to start with rotation of 180 degrees centered at the origin. And the way I'm going to see that is I'm just going to take one point, I'm going to rotate it the 180 degrees, and I'm going to see where it lands. So I'm going to take B. So that's 1, 2, 3, 4, 5, 6. 1, 2. And if we rotate it 90 degrees, it would be like that. And if we rotate it 180 degrees, they'll be like that. So I'm going to start at the origin. 1, 2, 3, 4, 5, 6. 1, 2. And it doesn't land where B prime is supposed to land. So I've knocked out the rotation of 180 degrees centered at the origin. Okay. Let's knock out, well, let's see if we could take on the other rotation next. That's a rotation of 180 degrees centered at 1, 1. And once again, I'm just going to pick a point. I'll do A this time. One, 2, 3, 4, 5, and 1. So I'll rotate it the other way, it doesn't matter. 90 degrees would be this way. 180 degrees, it doesn't matter if you go clockwise or counterclockwise. And then 5 and 1. So I'm going to start at the center. 1, 2, 3, 4, 5, 1. That does land where it's supposed to land. You can try it out for the other points, but that's the answer we're looking for. We can check out the other ones and see why they wouldn't work. So in answer choice number 2, a reflection over the line y equals negative x plus 2. I'm going to graph that line. The y-intercept's 2. The slope is negative 1. So down 1, left 1, down 1, left 1. And I'll get some points in the other direction. And I think we can see that that's not the line that's going to flip over, right? You're probably visualizing if it was going to be a reflection, it would have been something like that. But also, if we're reflecting it, right? Like if the line was somewhere here and we were reflecting it and it fell like this, that would be C, but this would be B prime, and this would be A prime. So the orientation wouldn't match up because A would be on the wrong side and B would be on the wrong side. So a reflection wouldn't work in this situation. And looking at the orientation of where the points are going to land can help you determine that right away so that you don't even waste your time with the reflections. Okay, here, I'm not going to use the grid. You can use the grid if it's helpful to you. So we have a 3:2 ratio that we're splitting the line segment into. That means 5 parts in total. We have line segment AB. I'm just going to do an estimate picture. 1, 2, 3, 4, 1, 2, 3, 4, 5 parts. And the 3:2 ratio means that there's going to be 1, 2, 3 parts, and then this point P, and then the remaining 2 parts after that. So the point is going to be located closer to point B than point A. So point B is going to get the heavier weight. Since there's 5 parts in total of the line segment, the weights that we're going to be using are 3/5, because 5 is the total number, and 3 is one of the pieces of the ratio, and 2/5. And since the point is going to be closer to B, B is going to get the heavier weight, so B is going to get the 3/5, the higher numerator, whereas A is going to get the smaller weight. I would separate by the x and the y coordinates. That's what I like to do. And once you separate it by the x and the y coordinates, you can take the 3/5 weight and you can apply it to the x coordinate from B and the y coordinate from B. And then we can take the 2/5 weight and we can apply it to the x coordinate from A and the y coordinate from A. And then we can just type into our calculator. So we have 24/5 plus -4/5. That's 20/5, which is 4, but you could just type into your calculator. I just don't want to switch back and forth my screens over here because it gets annoying. So I have -3/5 plus 10/5. That's -7/5. That doesn't work out nicely. Okay, and there we have it. The equation of the perpendicular bisector of JM. So the perpendicular bisector of JM is going to pass through the midpoint of JM, and it's also going to create right angles. So since it creates right angles, it's perpendicular. So we're going to need the perpendicular slope. And in order to do that, first I need the slope of JM. And I'm going to use slope formula. And if I plug in, -9 minus 1 over 7 minus -5, -10 over 12, and in simplest form, that's -5 over 6. So then the perpendicular slope would be the opposite reciprocal, which would be 6/5, opposite signs and flip the fraction. So I have the slope I'm using, and now I just need the point that it's going to pass through, which is the midpoint of JM. So I'm just going to find the midpoint. I'm going to use midpoint formula, which I'm going to average the x coordinates and then average the y coordinates. It's supposed to be plus 7. There we go. And then 1 plus negative 9 over 2. Okay. And now I have my midpoint. So now that I have my point and my slope that I'm going to be using, I'm going to use point slope form to write the equation of the line. Point slope form has the following format. And all I have to do is plug in the slope for m and the x and y coordinate of my point, which is the midpoint for x1 and y1. So we have y minus negative 4. The perpendicular slope that we're using is 6 over 5. And then x minus 1. And you can leave it like that, or you can rewrite it as y plus 4, because minus minus does make a plus. Here, we're going to write the equation of a line parallel to the given line passing through the given point. So first I'm going to put the line that we're given into y equals mx plus b form. So I'm going to subtract 2x from both sides. And then I'm going to divide by negative 3. And I can see that my slope is 2/3. And since it's a parallel line, I'm going to use the same slope. So I'm going to be using 2/3. They already give me the point it's going to pass through. So I'm going to use point slope form. And I'm going to plug in my y coordinate of the point, which is negative 5. My slope for m, which is 2/3. And the x coordinate of my point that I'm given, which is 6. Once again, you could rewrite this as y plus 5, but this is totally fine. Perfectly good equation of the line. Here, we need to find the area of triangle ABC. So what I'm going to do in order to find the area is first I'm going to box the triangle. And when you box it, just make sure that you pass through all of the vertex points. And notice how it creates 3 right triangles. Let me find the area of the whole box. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 9 times 8 would be the area of the whole box, which would be 72. And now I'm going to find the area of the right triangle. So area of triangle 1, area of a triangle is 1/2 base times height. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So that's half of 36, which is 18. And now I'm going to find the area of triangle 2, which is 1/2 base times height. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Half of 28 is 14. And then finally, triangle 3. 2 this way. 1, 2, 3, 4, 5, 6, 7, 8 this way. So that's half of 8 times 2. So that's half of 16, which is just 8. So 72 minus 18 minus 14 minus 8. And let's see what that is. I'm going to type that into my calculator right now. Minus 18 minus 14 minus 8. And we get 32. So the area of the triangle that we're looking for is 32 square units. For question number 11, we're dilating line AB by a scale factor of 2 centered at point A. Evan thinks the dilation of AB will result in a line parallel to AB, not passing through A or B, so like a separate line. That's what Evan thinks. Nathan thinks that the dilation will result in the same line as AB. So Nathan thinks it's going to be the same. Who is correct? Nathan is correct. Nathan is correct because when you are dilating a line and the center of dilation is on the line, it results in the same line. Evan is correct that when you dilate a line, any line, it is parallel, so it has the same slope as the original. But if it was centered at the origin instead of at point A, Evan would be correct that it would be a separate line. When you're centered at the origin, let's say this was the equation of the line. If we were centered at the origin, we would keep the slope. I'm trying to write y prime, but my pen's being weird. We would keep the slope because dilations preserve parallelism and make parallel lines. And then we could take the y-intercept and we could multiply it by the scale factor, which is 2 here. 2 times 2 is 4. And that would be the dilated line equation if you were centered at origin. So if we were centered at the origin, Evan would be correct that it would be a parallel line, but it would be like a separate line. Okay, here we're going to describe a sequence of rigid motions that would map ABC onto DEF. I personally prefer not to do rotations if we do not have to. But here I think I might actually do a rotation. I think I might do a 90-degree clockwise rotation. It's not the only way that you can do this centered at the origin. So I'm going to do that real quick and see where it lands. That will land here because it's 1 and 1. Let me do some of the other points as well. Oh, so C is 2 units from B. So C will land here. And then A is 1, 2, 3, 4 units from B. 1, 2, 3, 4. That wasn't too bad. It was nice numbers for this one. Okay, so that's a rotation of 90 degrees. And then it would require a translation to move A prime onto D prime. That would be 1 to the right and 1, 2, 3, 4 down. So one possibility is a rotation of 90 degrees clockwise, centered at the origin, followed by a translation of 1 unit right and 1, 2, 3, 4, and 4 units down. This is not the only possibility. Whatever possibility that you did, just make sure that you try it out on the grid to see that it actually does work, and make sure that you fully described your transformation. If you did reflection, what line did you reflect over? So that should be part of your explanation. For number 13, which is the construction, please see my video. You can click on fall semester videos, but please see my separate video on constructions. This is the perpendicular line through a point construction, and you can find it on my fall semester videos on the video link doc on Google Classroom. Okay, we have one more question to go in this video. And I'm gonna just take a moment and I'm going to graph the triangle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 1, 2. There we go. And first, we're gonna prove that triangle PET is a right triangle. To prove it's a right triangle, I have to prove that it has a right angle. And in order to have a right angle, I must show that I have perpendicular lines, because perpendicular lines make right angles. And if I want to show lines are perpendicular, I need to show that there are opposite reciprocal slopes. So this is going to require a slope formula. So I'm going to write small and I'm going to put part A over here. So I can kind of see that angle P is where the right angle is going to be at. So I'm going to find the slope of PE. Let me write slope of PE. And I'm going to find the slope of PT. And I think that should be enough to show the right angle. Okay, write your formula, which is y2 minus y1 over x2 minus x1. Using points P and E, that would be 8 minus 4 over 6 minus negative 6. So that's 4 over 12. In simplest form, that's 1/3. The slope of PT would be negative 2 minus 4 over negative 4 minus negative 6. That's negative 6 over 2. And in simplest form, that is negative 3. And look at that. If I put this over 1, it's easier to see. We have opposite reciprocal slopes. So now I just need to put a concluding statement explaining what my work shows. Since PE and PT have opposite reciprocal slopes, they are perpendicular, so they make a right angle, showing that triangle PET is a right triangle. Now it says to state the coordinates of N, which is the image of point P after a 180-degree rotation centered at the point 1, 3. So let me dot that point. 1, 1, 2, 3. And we're rotating P. I'm going to erase this after. So that's 1, 2, 3, 4, 5, 6, 7 this way, and 1 this way. So if I rotate it 90 degrees, and it doesn't matter the direction because 180 degrees is the same in both, so I'm just going to do clockwise. It'll look like this. And then if I rotate it again, it'll look like this. So starting from the center, I'm going to do that movement. Down 1. 1, 2, 3, 4, 5, 6, 7. And here's the point I'm looking for, point N. And that has the coordinates 1, 2, 3, 4, 5, 6, 7, 8, 2. Put that here. 8, 2. There we go. And let me just give myself some more space. I'm going to erase the work I was doing before. You shouldn't erase your work, but I just don't want this to get more confusing, so I want to have space. So now we're going to prove that the resulting quadrilateral, now that we found point N, is a rectangle, but not a square. So in order to be a rectangle, it first has to be a parallelogram. I don't have enough work yet to show it's a parallelogram because I only found the slope of PE and PT. So I need to find the slope of the other two sides. So I'm going to just label this part C. So I'm going to find the slope of TN, and I'm going to find the slope of EN. So the slope of TN, and let me just write N over here so I can reference it for myself, because otherwise it's hard for me to see. So TN, 2 minus, oops, my pen's being so weird, 2 minus negative 2 over 8 minus negative 4. And that's 4 over 12, which is 1/3. And when I find the slope of EN, I should expect it to be negative 3, but I do have to show the work. 2 minus 8 over 8 minus 6. And that's negative 6 over 2, which is negative 3. And now the slope of PE and the slope of TN are the same. And the slope of PT and the slope of EN are the same. So I just need to put a concluding statement explaining how I know this is a parallelogram. Since both pairs of opposite sides have the same slope, they are parallel, making PE and T a parallelogram. In part A, we proved that we had a right angle at P. So now we can just simply state why it's a rectangle because we already have enough work to prove it. Since there is a right angle at P, PENT is also a rectangle. Remember, a parallelogram with a right angle is a rectangle. But now we have to show that it's not a square. And in order to be a square, it needs to be rectangle and rhombus. So what I need to do is I need to prove a rhombus property or try to prove it and show that it doesn't work out. So I don't really want to use distance formula, so I'll just use slope. In rhombuses, one of the properties is that the diagonals are perpendicular. So if I can show the diagonals are not perpendicular, then I won't have a rhombus. Not the only way you could do it. You could also do it with the adjacent sides being congruent or not congruent since we're proving it's not a rhombus, and that would require a distance formula. So I'm going to find the slope. I'll do it over here. Slope of PN, one of the diagonals, and the slope of ET, the other diagonal. So let me get my coordinates. So that's 2 minus 4 over 8 minus negative 6. And that is negative 2 over 14, which is negative 1 over 7. And then I'll do ET, negative 2 minus 8 over negative 4 minus 6. And that's negative 10 over negative 10, which is 1. So those are not opposite reciprocals. Since diagonals PN and ET do not have opposite reciprocal slopes, they are not perpendicular, so PENT is not a rhombus. Since it is not both a rhombus and rectangle, It is not it is not a square. And there we go. We are finished.